IFHE monthly webinar. Good morning, everybody, and welcome to the IFHE monthly webinar. We will get started in just a moment. Well, great. Well, thank you and good morning, everybody. Thank you for joining us from around the world. We are excited today to host this IFHE webinar. We are excited because we have Danny Hallel, who played an instrumental role on putting together the RAC Plant Sustainability Guide. So today's speaker, Danny Hallel, also brings over 50 years of experience in the HVAC and refrigerant industry. He began his career as a technician in 1973 and later earned his engineering degree from Southern Illinois University in Carbondale. Danny has held a wide range of engineering roles within major HVAC manufacturers and has also served on staff with both ASHRAE and ACCA. He's a lifetime member of ASHRAE and has contributed to several key standards and committees. Uh, he's been active with the IIAR for the past 7 years, serving on multiple committees and leading the development of education for IIAR, Standard 6 ITM, IIAR CO2, and the IIAR Piping Handbook. He is a passionate educator. I just learned from speaking with him. And he also runs his own consulting firm, Enthalpy Engineering, focusing on commercial system design and education. We're excited to have him here today. Before we hear from Danny, just a couple of housekeeping items. Firstly, as you'll hear in his presentation, the learning objectives include learning how to navigate the unit portal for RAC Plant Sustainability Guide, and learning more about how to walk through the guide and major components. The audience for this webinar is worldwide, and so there is an option to change your caption language if your preferred language is not English. To do so, simply find the button on your screen that says Show Captions. You may need to touch the More ellipsis in order to get there. Click on My Caption Language, and there you can change it from English to a different language. During and after the presentation, we invite questions and answers. We'll answer most of the questions at the end of this session. You can access the question and answer bar by clicking on the question mark. You may need to click on the More ellipsis in order to access the Q&A function. Before we hear from Danny, I'm excited to introduce Walt Vernon, who is the acting president and president-elect of the IFHE, to share a few words. Walt?
Thank you, Troy. Yeah, I want to say how thrilled I am that we are able to welcome Danny here. IFHE is working hard to do many things, but one of the things that we're really trying to do is to build strategic relationships with other international organizations, and bring the best of IFHE to them and the best of them to IFHE. And so we are among those organizations is the United Nations and ASHRAE. And so to be able to have Danny here talking to us about the work that they're doing for the benefit of us and IFHE is really exciting. I did want to say that we are actively updating the website for IFHE, and we will have much better information about coming webinars. And we're also going to post all of the previous webinars for free on the website, so you can catch all the ones that have come before as well as the ones that are coming. And the other thing that I wanted to note is that next month we have a very special webinar. Next month, we're going to do one jointly with the International Hospital Federation. And the International Hospital Federation are the CEOs, the leaders of healthcare organizations. And so the focus really is on how design of infrastructure can intersect with delivering better clinical care and clinical outcomes. So that's a very exciting one. We'll host it again twice, so that different people in different time zones will have a time that's convenient for them. So there'll be more information forthcoming, both on the website and via email. So sign up for our emails and you'll be given all of that information. So I'm just thrilled to have you, Danny, and I'm going to turn the program over to you.
Well, thank you, sir. Let me switch the screens here. We should be good. Troy, can you see my screen?
You're all set to go.
Very good. Well, welcome to you all to the ASHRAE United Nations Environmental Program training session on the RAC Plant Sustainability Guide. This guide was developed by 11 different experts in the RAC field under the direction of the ASHRAE Multidisciplinary Committee. It was further peer-reviewed by experts in 7 different countries. I do wish to thank the International Federation of Healthcare Engineering for the opportunity to present this program, and I hope that you glean some knowledge from this to make your business model more productive and more profitable. This presentation covers the why, the who, the what, and most importantly, the how of RAC plant maintenance and sustainability. The content is split into 9 sections, which will be covered in the coming slides. Why is the RAC Plant Sustainability Program needed? Well, the checklists and guidance sheets included in this program are critical resources for RAC plant operators as low GWP alternatives become available to the market. Many of these solutions have flammability concerns, and compliance with safe handling practices is necessary to eliminate risk to humans and property. Regulations also mandate increased tracking and reporting of refrigerant inventory and system leakage. The RAC guide, the toolkit, establishes a required mindset for each one. A positive mindset is essential when developing sustainability-centric attitudes among the service team. O&M best practice checklists. These are practical tools that we'll go through that will help implement the required and recommended practices. And then we have as well a measure of success. How do you know that when your work is done that it was successful? Well, we provide some help there, including emphasis on preventive maintenance through regular inspections and upkeep to the RAC equipment. So how does one access the tool? Well, the website is www.ashrae.org. Once on the ASHRAE website, click on the Professional Development ribbon bar here in green, and click on the portion down here in purple called the ASHRAE UNEP portal. Once you click that, you will go to the page entitled ASHRAE UNEP portal and scroll down the screen. As you scroll down the screen, you'll see a little board here which says check marks or checklists for RAC plant sustainability. Check that. When you click that, you will get the list of checklists as well as a little ribbon on the bottom that says register for free checklist access. Click that ribbon and you will only have to register once, but you will have to click this ribbon every time to gain access. But you'll only have to register once. After you register, you will see 9 ribbons show up with the 9 different sections of the tool. They include safe storage and proper handling of refrigerants. This is for all users of the tool, from new technicians all the way to 20-plus year veterans. Periodic leak checking and proper documentation. In addition to the guidance here, you should check your local regulations as it relates to proper documentation for refrigerant handling and refrigerant leak detection. The third one is preventive maintenance of equipment. Following these procedures will extend equipment life and overall reduce costs. Preventive maintenance of automatic controls. Follow these procedures will prevent failures that can cause product loss. Energy efficient operation. These costs related to these procedures will pay back in energy savings. The next one is proper commissioning and recommissioning practices. Knowing how the system is functioning today will set up how the system functions tomorrow. In other words, when you set this system up, you should know what the requirements are by the designer, and you should see that the unit or that the system is functioning at that level before you release the unit to the owner. What's interesting here is that now you have documented through the commissioning process everything about that system, so that 3 years from now, 5 years from now, or when some other serviceman comes to service that unit, he knows what the baseline is for the function of that system. The next one is proper disposable equipment and refrigerant. The impact to the environment can be devastating if the disposal of these systems are not handled well. Not just the refrigerant, but the equipment as well. The eighth one is competencies of operating and service personnel. We, in this guide, provide competencies of 5 different levels of technicians. It's important to know at what level your technicians are operating at so that you, as a service provider, can ensure that the person that you're sending to the job is qualified to complete the work. And finally, in the annex, we provide requirements of tools and servicing. So let's look at a couple of the ribbons. If we pull down the first ribbon, safe storage and proper handling of refrigerant, you will see 4 PDF files. One of them is labeled Checklist for Notebook for safe storage and proper handling of refrigerants. The next one is the checklist poster. We'll go through both of these. Then there's a guidance sheet. We'll talk about that as well. And then also resources. Now, when we get to resources, one of the things that I'd like you to remember is that this type of guide lays a foundation for good practice. It does not provide 100% of everything that you need. When we developed this guide, we developed it understanding that there are experts worldwide that have already written documents to help you understand what's going on within your system. In this resources section, we give you some guidance as to what other documents or standards or codes you may need to complete your work. Some of them are free, some of them cost. We'll just deal with that as we can. So if we click on the first one that says checklist for notebook, this is what the checklist looks like. We start off each of the best practice checklists with a mindset. What is the mindset for this one? This is safe storage and proper handling of refrigerants. It is refrigerant is an asset, not a consumable. Back in the day when I started in this field 52 years ago, refrigerants were relatively inexpensive. I remember paying 20 cents for a pound of R12. 22 cents for a pound of R22. Today, that's not the case. Refrigerants can cost anywhere from $20 to $50 a pound. And so therefore, we have to treat it differently. We have to treat it as an asset and not as something that we just consume. Why did we write this safe storage and proper handling of refrigerant checklist? Well, we take extreme care to avoid direct ingestion of refrigerant vapors. Refrigerants are heavier than air and will replace air in the confined space. Just because a refrigerant is rated A1 means that it is low toxicity and non-flammable. And just because it's low in toxicity doesn't mean that you can safely breathe it. When you do breathe these refrigerants, they do replace the oxygen that's in the air that you're breathing. And obviously, that is not a good situation. Our objective was to minimize the environmental impact of refrigerants, protect workers, and ensure efficient equipment operation. And what is our measure of success here? Well, no environmental incidents. In other words, no major leaks, no safety incidents, and reduced refrigerant leakage during storage and handling of the refrigerant. That goes for secondary fluids as well. It should be noted that a few refrigerants are lighter than air. A couple examples are ammonia and methane. So if in fact you are dealing with a refrigerant that is heavier than air and you know there is a major leak in the room that you're in, obviously you want to walk out. But if there is a refrigerant that is lighter than air, such as ammonia, you need to get down and crawl out of the room rather than walk out of the room. This checklist calls out major areas of concern. They include 6 checks under refrigerant storage, including signage, leak detection, ventilation, and security. There are 22 checks under packaging guidelines. There are 4 checks listed. Sorry about that. There are 4 checks listed under the topic of storage lines, including bulk refrigerant storage and equipment. And there are 2 checks shown under environmental considerations, including contaminant control and the Department of Transportation requirements. Now, these requirements are specific to your area. So again, ensure that you check with your local codes people to understand what the requirements are as far as the transport of particular refrigerants. Under that same ribbon, you'll see checklist poster. Well, this poster has exactly the same checklist items that the checklist we just went through has, but it is put up in a poster style so that you can laminate them and put them either in the machinery room or your maintenance office. The notebook-sized files and poster-sized fill 2 important needs. The notebook-sized file can serve as a permanent record of the work that was completed. So as a checklist form, you can date the form, and as you do, as well as sign your name as to the technician that did the work, you can check the form to tell the next person or yourself so many months or weeks or later that this particular work was completed. The poster size files can again be laminated and either put in your machinery room or your maintenance office, and the same function can happen. If we move next to the guidance sheet, these sheets provide background information on how and what background came to develop the check sheets. In the example here, the guidance sheet explains why safe handling of equipment, safe handling of refrigerants is so important. This guidance sheet speaks specifically to the refrigerant as a chemical and its impact to the HVAC in our industry. The technician mindset and procedures must always keep safety first in mind, and therefore in your work as well. This is not only safety for the technician, but it's to the personnel on site, the owner, and the environment. The guidance sheet also lists additional information and resources when additional information is needed. For instance, depending on your local regulations, there are specific safety standards that may apply to your system. In parts of the world, ASHRAE 15, which is the safety standard for refrigeration systems, may apply. In other areas, ISO 5149, which is the ISO version of ASHRAE 15, may apply. Or if you're in Europe and you follow European national standards, EN 378 may apply. So check with your local jurisdiction to find out the standard that applies to where you are. It is important to build a relationship with your local jurisdiction, with your inspector and the inspection team. This relationship will help when issues arise to negotiate solutions for a problem. And last, and we've talked about this a little earlier, we do provide a list of resources for each of the individual sections. And you can see here, safe handling and proper handling of refrigerants. You can see we listed here ASHRAE 15, ASHRAE 34, Guideline 6 from ASHRAE as well. Material safety data sheets can be a great resource. And then refer to other standards such as ISO 817, ISO 5149, parts 1, 2, 3, and 4. And also, let's not forget about the IEC standard 60335-1-2-40, which covers residential air conditioning and refrigeration equipment, and 60335-2-89, which covers commercial refrigeration. The second ribbon, blue ribbon, is periodic leak checking and proper documentation. When you work with this section, be aware that documentation requirements for each country may be different. It may be even different in each area of a country. Here in the US, we have our states, and our states require different documentation depending on the state that you're in. So you may want to check that depending on where you are in the world. The third one is preventive maintenance of equipment. Now, this ribbon's slightly different in its output. We do give the checklist for the notebook. We give the checklist for the poster. We give the guidance sheet. We as well give resources. But we do have 9 additional documents in here, and they are preventive maintenance work orders. And they include the air-cooled chiller unit, that is a refrigeration system using ambient air as the heat rejection medium, a water-cooled chiller unit, a refrigeration system using water as the heat rejection medium, a cooling tower, a device that reduces the temperature of a coolant system by rejecting heat to the atmosphere, a chiller system water pump, that is the pumping system for a water-cooled chiller unit, a fan coil in a VRF system, that is the indoor fan coil on a VRF refrigeration system, a fan coil unit using chilled water, a fan coil unit in a standard DX system, an outdoor VRF system, that is the outdoor condensing unit serving a VRF unit, and a parallel rack. That is the complete system, let's say in a supermarket or large warehouse where we have multiple loads running at different temperatures. Depending on the work order that you open, the task will be specific to that equipment. You may use several different of the work orders in these systems in your building. Now, what's really interesting about these work orders is we not only give them to you in PDF in both A4 size and the US size of 8.5 by 11, we also give them to you in Excel. So if you click on the Excel version, you will be able to be completely interactive with this, and you can set this up to match your equipment, which is really important because not all systems are the same.
Let's look at just one of the.
Let's look at this PM work order. At the top, here we have the listed owner, What building is this equipment in? What year was it installed? Any and all information about this unit, including voltage, serial number, type of equipment that it is. Below that, we have system details. What type of TXVs or what type of a metering device does it have? Is there a subcooler? Are there EPRs? Are they electronic EPRs? What type of compressors are there? Are there liquid solenoids? Are there suction solenoids? Now, this one again is specific to a parallel rack. There are some special instructions here for the technician. Bring any tools that may be required. Turn off the power at the best location for the service of whatever component you're working on. And there are other 7 different special instructions to follow. On the next page of the work order is, in this case, 25 very specific things, as well as the time it should take you to check these things. So this first one here is done monthly. If it's under W, that's weekly. M is monthly. Q is quarterly. S is semi-annually, and A is annually. So every month, you should check items 1, 2, and 3. 1 being check compressor motor amps against the nameplate. Why is this important? Well, if you've lost a portion of a motor winding or all the motor windings, you can find out what's going on within that motor to check. You can see if you'll be able to check to see if there's ground. You'll be able to check different things with that motor amps. You can also check the motor amps against the load that is there. The less the load, the less amps we're going to pull. Check all electrical connections to ensure that they are secure with no loose ends or frayed ends on the wiring. This I have found to be I'm not going to call it huge, but it is a very important thing in that when there are frayed ends on stranded wire, they're not underneath the screw holding it in place. We can develop a lot of heat within those frayed ends, and it may be hot enough to start a fire. You need to also check refrigerant piping for secure support structure, just to ensure that it is all nice and tight. In this case, these 3 things are done monthly. Now, if you do them every month, if you come over here to the right-hand side, you'll see that those 3 checks take 20 to 30 minutes to complete. And if you do them every month, you'll spend 4 hours in a given year making those checks. Under quarterly, you can see there is record mega ohm value for each winding in the compressor, check the oil levels, you can check oil leaks at all the connections, you can check the function of pressure transducers, you can see all the things here that you need to check quarterly. It will take you about 2.5 hours to do all of these checks. And if you do them every quarter, you're looking at 10 hours worth of work over a given year. Semi-annually, there are 2 checks to make. Annually, there are another 11 checks to do annually. If you do all of these checks all year long, all the quarterly, all the monthly, semi-annually, and annually, you will spend about 18 hours checking this particular rack to ensure that all the things that are running in your system are running the way they're supposed to. Ask yourself the question, is an 18-hour investment over a given year worth the time to ensure that your system continues to run as fault-free as possible? A few more bands down, you will see energy efficient operation. There is the checklist for energy efficient operation. The mindset here is an efficient plant and an economical and sustainable plant. Why? Equipment performance should be measured to ensure it's performing as intended. Understanding that energy today is incredibly expensive compared to the way it was several years ago, and it's not going to get any better. right? If energy costs are going to continue to rise. So if you can do some things to save some energy, it is normally worth the investment. But that again, I can put in a subcooler that will save energy. But if I don't service that subcooler following a preventive maintenance plan, that subcooler may cost me more energy than if it's not functioning. It will cost me more energy, and the payback that I invested in the capital of that subcooler will not pay for itself. So it's not just installation of this equipment, it's also the preventive maintenance. What's my measure of success? Well, minimizing total energy use. You should, as a owner of a building, know what your electrical costs are, as well as how much power are my systems pulling. And you can make that comparison year to year and help, again, put in a preventive maintenance program to keep that cost low. There are some checklists here, again, to look at from an energy standpoint. That includes just general observations, measurement of operating parameters, power consumption readings, and these are for all of the different systems that we talked about earlier. That is chilled water systems, AHUs and FCUs, air coolers, air-cooled refrigeration systems, VRF systems. So we are giving you in this guide specific sections that you can check from an energy standpoint.
There are 2 more unit types.
One of the things that we also provide here are competencies of operating and service personnel. Training is so important. That's why you're attending this seminar, right? Is that you want to be better educated in areas where you're looking for additional knowledge. Why? Well, competent operating and service personnel contribute to lower system downtime, improved equipment performance, reduced safety incidents, and reduced unintentional refrigerant releases. Requiring core competencies for plant operators and technicians will lead to improved job opportunities as well as sustainable plant operation. The objective here is to achieve sustainable and energy efficient RAC operation by ensuring that your operators and your service personnel have the necessary core competencies to complete their work. Measures of success, again, lower system downtime, fewer safety incidents, and full redundancy and backup for operating and servicing personnel. In this particular case, we do provide some background or some base information as it relates to what are some of the fundamental skills that a technician needs. And that includes demonstrating mechanical aptitude, basic understanding of sustainability objectives, performs measurements and calculations, performs electrical tasks and bench work. It's important that these technicians have a base knowledge. There's some specialized knowledge that, again, technicians should have, and they're all listed here. And then there is the understanding the importance and proper use of PPE, personal protective equipment. Your technicians should have safety glasses, steel-toed shoes, and depending on what other things they're doing, if they're handling refrigerants, they should be wearing gloves. If they are up on a roof, and climbing ladders to get to that roof, there should be safety straps. So understanding all of the pieces of that puzzle are very important as it relates to safety equipment. Our guidance sheets for these competencies are, I think, very complete and you can use as listed here. Competence is the ability of an individual to do a job properly. Competency is a set of defined behaviors that provide a structured guide, enabling the identification, evaluation, and development of skills in an individual employee. Assessment is one of the methods implemented by a country or other authority to validate an individual's competence. We're here in the US, we're looking at putting together what is a competent individual to work on specific systems. It's not an easy task, but this right here can help. What is the mindset? Again, to train, to maintain, and sustain. And the best practices that we're providing are 5 levels of technician experience. Level 1 is an entry level with 0 to 1 year of experience. This is the guy that's just gotten out of maybe a technician school. It possibly could be the son of a trained HVAC professional. It could just be a person that is interested in working in the field. The apprentice level with 1 to 5 years experience. So here's a person that has been working in the field under the tutelage of a trained journeyman or master level technician to learn how and why to do particular work. And he shouldn't be standing by watching. He should be doing with the technician being there. You learn by doing, and it's really important that we do that. The technician level with 6 to 10 years of experience. By the way, we do go through further on in this guide, what are the different competency levels of each of these technician experience. So we'll get to that in just a second. We have a journeyman level, 10 to 20 years of experience, and then a master level with 20 years plus experience. Each of these have specific training and competency levels. When the refrigerant circuit design is completed, the component manufacturing is completed and shipped. The operation success lies in the hands of the installing contractor. In this case, the installing contractor has to be prepared and be safe. Again, functioning with or working with personal protective equipment is incredibly important. And having the proper tools is also very important. In the book, there are specific tools that should be available, both hand tools as well as tools to help you find leaks, tools to help you read pressures in the system. These tools are really required if you're going to do service work on systems. One of the other things that we provide in this guide are leak detection methods. The most common method is soap and bubbles. We all know that soap and bubbles will find leaks. Unfortunately, a soap and bubble can reliably find leaks that are 10 ounces a year and greater. The standard set by ASHRAE as well as others, including ISO, says that the leak rate should be less than 1/10 of an ounce per year. Using soap and bubbles, it takes about 45 minutes to find a leak that is at 1/10 of an ounce a year. No one's going to stand around and look at 45 minutes at every joint to see if it develops a bubble. So Soap and bubbles do find leaks, but only the larger ones. It is intensive, and sometimes it can be aggressive to the materials depending on the soap that you use. The next type of leak detection is the electronic refrigerant leak detection. This is the most commonly used, and these can find leaks at 1/10 of an ounce a year or greater, depending on how you calibrate the unit. But these are very common. They can be found nationwide or worldwide, and are worth the dollars to purchase because they are so good at finding leaks as long as they're calibrated well. Be sure that the leak detector that you use is set up for the refrigerant that you have in the system, and that is calibrated for the level of leak that meets local and federal regulations. For example, HFC detectors are not compatible with hydrocarbons. So if you have a system that has a hydrocarbon refrigerant, you can't use an HFC detector to find it. And that's vice versa as well. So ensure that you're using the right detector. Here at the bottom, we say never mix refrigerants. Please don't do that. If you have a refrigerant in your system and you're looking to replace refrigerant that's in that system, or should I say add to it because it's leaked out, do everything you can to replace the refrigerant that's in that system with that same refrigerant. I have seen where people have taken propane and put it into an R410A system because they couldn't find R410A. Will it work? Yes. There's only one minor problem, and that is now this refrigerant that before was slightly flammable because it's R410A. Excuse me, 410A is not slightly flammable. Is a blend, now becomes flammable, and therein lies a problem. So never mix refrigerants. So who else can benefit from this? Well, you as a technician and your maintenance company benefits. Why? Well, wouldn't it be great if you could eliminate your emergency phone calls at 3 o'clock in the morning? Wouldn't it be nice to implement a preventive maintenance program knowing that the result is that your emergency calls are reduced? Building owners can obviously benefit from the use of this guide, and others can benefit, including governments. The guide can be a model for establishing requirements and compliance paths for refrigerant emission reductions and reduced energy use. This guide can also be the basis for safety and sustainability regulations. RAC equipment suppliers, as well as their distribution channel, can benefit from this. Better performing equipment rooms are characterized by more efficient equipment. The guide can also help owners select the competencies that lead to the best performing projects among a wide diversity of options. Let's assume for a moment that the owner is large enough that you have your own maintenance crew and that you don't farm that work out. Well, now you have given this equipment or this guide to your own staff. Let's assume that you're using a secondary firm to do all your maintenance. Well, now you can help them develop their own preventive maintenance system for your equipment. The value in this guide lies in the potential to close knowledge gaps among operators, owners, managers, and policymakers to operate and maintain RAC plants and systems in a safe, efficient manner. So if we can summarize, We ensure that the work performed on an RAC system is consistent and routinely completed. We reinforce the need for preventive maintenance. We keep mechanical systems running as designed and keep products at the prescribed temperature without interruption. One of the things I want to mention here is I still do some service work on the side. I actually have a system that is using still one of the R12. This system has run for over 50 years with the same compressor, same evaporator, same condenser, same everything. We are religious about doing maintenance on this system every quarter. This unit, again, has run for 50 years. It has never been, we've never added refrigerant to it, so it's never had a leak. And I think it gives credence to the fact that preventive maintenance works. This tool provides tools to train technicians to help them follow maintenance schedules in a timely and inclusive manner. It provides a system by which energy efficiency, safety, and compliance with local and national regulations are at the forefront. And the results in a reduction of overall life cycle costs, it improves facility safety, and provides long-term positive effectiveness. That is the end of my presentation. I hope that you've gleaned something from this. I'm hoping that you have some questions. We do have some time available. And again, the website is www.ashray.org. And you can go directly /UNEP-RAC checklist. Or you can just go to the ashray.org site and pull down the menus as we talked earlier. Are there any questions?
Perfect. Well, Danny, thank you so much for that presentation. As you mentioned, we do have some time for questions. If you're asking a question, feel free to enter it in the Q&A function in the Zoom webinar. I see a couple of questions there already. As others are gathering questions, I will ask you this, Danny. Can you share how you collaborated with a UN environmental program to create this guide? Why was UNEP interested in this?
When I first got involved, UNEP, from what I understand, went to ASHRAE and said, hey, we need some help across the world, especially in A5 nations, to help them understand their RAC systems, refrigeration air conditioning systems, and we need to help them figure out what they need to do to ensure that leaks are reduced as much as possible and that energy usage can be as low as possible. And so ASHRAE put together a group. I was one of them. There were 13 of us originally, and we sat down and said, okay, if we're going to provide a guide, how would we do it? This is the end result. So UNEP is looking to not only help those nations that are A5 countries, but also, honestly, since this has started, I know of 2 maintenance companies here in the US that are using this guide. So it doesn't only apply to A5 countries, it can apply to any business that is in the service business of RAC systems.
Excellent. Danny, can you remind the audience what A5 countries are?
Those are what UNEP calls underdeveloped nations. An example, I believe, is like Laos and portions of India, Nepal. There are countries in South America. There are countries in Africa that all meet the requirement of what they call A5. But honestly, those are the ones that need the help the most.
Got it. Okay. So again, a reminder, please feel free to put questions in the Q&A function in your Zoom application. The next question that's been submitted, Danny, is this. How can I best use this guide to help upskill my maintenance staff? What's the best way to get started?
Best way to get started, go to IFHE.org, click on the, let me go back to this original piece here. Go back to professional development, click on the ASHRAE UNEP portal. You can see there on the lower right-hand side, you will see this screen. You'll move down the screen and see checklists for RAC plant sustainability. Let's assume for a moment that you have a multifamily apartment complex, and you have a chiller on the roof. You have specific coils that are in each of the rooms within the apartment. And you have a condenser on the roof as well. Well, the best thing to do would be to come to here, go to the section that is labeled preventive maintenance of equipment. Look at your checklist, use the poster if you choose to, go to the guidance sheet and pick that equipment here, whether it's an air-cooled chiller, whether it's, if it's water-cooled, pick that. Download these PDF files, print them out. In the case of here, they don't have to be PDFs. They can be Excel files. So print the Excel file and talk with your main technicians and make sure that what is in this particular work order matches your equipment so you can change it within the Excel worksheet. And ask your technicians to follow now this work order, to do it weekly, to do it monthly, to do whatever tasks are required quarterly. That's how you get started. You just have to implement what's there. I do recommend that you look at all of the pull downs for all of the different equipment, just so that you get in the right mindset. Understanding periodic leak checking, understanding safe storage of refrigerants. It is all right there. It's just a matter of you getting into the website and starting to use the resources that are there.
Excellent. Thank you. Another question has come in. It says, refrigerants have great global warming potential, and the recommended and or permitted refrigerants seem to change very often. Is there a way my hospital can get ahead of this? And I would add, kind of how should, not just hospitals, but all organizations think about kind of the changing regulatory landscape, and is there a way for them to get ahead?
That's a very difficult question. Short story. Back in the day when I started in this industry 52 years ago, we had R12, R22, R502, and R11. And we used R11 as a cleaning refrigerant to blow out coils. This was way before we ever knew about the environmental effects that these refrigerants had. We didn't think about global warming. We didn't understand at the time ozone depletion and the effect that refrigerants have on that. And so we didn't ask ourselves those questions. As we started to understand and we came up with new refrigerants, believe it or not, in the world of ASHRAE and ASHRAE 34, that is the ASHRAE standard that classifies refrigerants and numbers refrigerants. We have over 100 refrigerants that we could use as a refrigerant in this RNAC industry. A lot of those refrigerants are outlawed now because they are blends with R12 or R22 or R134A, which have high ozone depletion, or they have high GWP. Because of all the different choices today, the manufacturers choose what they believe is the best refrigerant for their systems to meet whatever energy regulations are imposed in their system and where they sell it. Here in the U.S., 20 years ago, prior to 2010, if you had a residential air conditioner, it had R22 in it. In 2010, it started with R410A. Now, 410A, we've learned, has high GWP, and now we're using R32 or R454B. In the world of commercial refrigeration, there's about 7 different refrigerants that could possibly be in your system. All I can recommend is that if you're trying to figure out what is the best refrigerant for you, you can talk with the manufacturer of the equipment. You can talk with a professional engineer who is in this business. You could contact me through my email. I'd be happy to answer any and all questions that you might have relative to different refrigerants. But for the most part, when you buy a piece of equipment, it is designed with a specific refrigerant to meet certain requirements. Now, there are some manufacturers, like the manufacturers of parallel racks, where they rely not only on themselves, but they rely on their customers to tell them what refrigerant to use. So I hope that answers your question. It's difficult to really give an answer as to what is the best one, because it all depends on what your application is and what temperature you're running at.
Excellent. Well, Danny, thank you for that very kind invitation for the audience to reach out to you. I believe you had a slide with your email address, correct?
Did I? Let me look here if I did.
There are 2.
And I'm
No. Let me. I'm not sure I can.
But we will certainly include it in the follow-up
Okay.
If
Well, yeah. Just if you have a pen in hand, it is DANNY.HALEL at NTHALP engineering ENGINEERING.com, and that will come directly to me and my company. Do not hesitate to email me if you have a question, or if there's some way that I can help you.
Perfect. And with that, we just, on behalf of the International Federation of Healthcare Engineering, we want to say thank you to Danny for this presentation. And as a reminder, Walt highlighted the next presentation will be Bridging the Gap, the intersection between hospital leadership, design, and engineering in modern hospital facilities. That session will take place on Tuesday, March 3rd and Monday, March 2nd. Stay tuned for more. Thank you all so much for joining, and enjoy the rest of your day.
Thank you, Troy.
Thank you. Take care.